Hi, everyone, and welcome to this session on IBM I in the cloud now. I always like to start my presentations on the IBM I and new technology with this slide, because too many people think of the IBM I as on the left side of this screen, as a system that's limited to things like green screens and RPG and COBOL and CL programming, when in fact, anything you can do on any other platform, you can do on the IBM I. You want the latest in user interfaces like mobile and web, you can do that on the IBM I. You want to use open source, you can do that on the IBM I. You want to do modern DevOps, you can do that on the IBM I. And today, we're going to talk about how you can use cloud for the IBM I. And we're not talking about just having a cloud address for your IBM I, that it's sitting at someone else's location, but actually true cloud for the IBM I. So we're going to talk about what it means to be true cloud for the IBM I, where you can do everything with the IBM I in the cloud that you can do with any other platform in the cloud. So we're going to talk about instant snapshots. That is the ability to take a snapshot of your running production environment and create a brand new one that looks just like it. We're going to talk about backups to the cloud, where you can replace things like tape backups with backing up to cloud IBM Is. And instant capacity increasing and decreasing. So if you need additional capacity in your environment, you can grab additional capacity when you need it. And then we're going to talk about cloud DevOps and how you can do modern DevOps in a cloud environment. So we're going to talk about how you can leverage all the capabilities of cloud so that you can manage your IBM Is more cost effectively, so that you can do more with your IBM Is so you can become more productive, and so that you can simplify your day-to-day operations. So what are some of the things you can do with IBM I in the cloud? One of the first things you can do is you can clone your IBM I environments. If you need a new instance of your IBM I to do upgrade testing or to do application testing, you can create those right away. And it's not just creating a copy of the IBM I, but you can create a copy of the IBM I plus all of the other platforms might surround it. So you can get all of your IBM I applications, all your IBM I data copied, but you can also get your Windows servers and your Linux servers copied right along with it, as well as all the network settings to make it all work. So if you need to do an upgrade, if you're going to move, say, from 7.3 to 7.4, you can simply take a snapshot of your existing production environment, create a new one, run the upgrade from 7.3 to 7.4 and see if it works. And if everything works, great. You can then upgrade your actual production environment. If you have problems, you can destroy that environment, create a new one, and try the upgrade again and keep making changes until the upgrade works successfully. And then you can go upgrade your actual production environment. Same thing is true as if you're receiving packages from a software vendor. When you get a new release of the package, you can simply create a new instance of your environment, run the upgrade of the package, make sure everything works, and then upgrade your production environment. Or even if you're just making changes to your IBM I systems, you can say, I want to create a copy of my IBM production environment, and then run the upgrade, install those new changes, and see if everything works. You can also grab additional capacity if you need it. So when you have an on-premise system, you really have to buy enough capacity for whatever your spikes in processing might be. Let's say you have a need for additional capacity at month end to do month end processing, or you're a seasonal business and you need extra processing power for your high season. Or you have developers who only work 8 hours a day and you don't need the capacity for development for all the rest of the time. When you're running in the cloud, you can say, you know what, I'm going to just buy the minimal amount I need for the day-to-day processing of my company, but I will grab additional capacity when I need it. So at month end, I'll get some additional capacity, I'll use it, and when I'm done, I'll shut it down. Or I'll have additional capacity during the hours that my programmers are working on the system, and when they're not, I'll shut that down. Or during the high season for my business, I'll get additional capacity as I need it, which means I can manage my environment more cost effectively because I'm only paying for what I'm actually using. I'm not carrying a lot of excess capacity that I have to pay for. I also eliminate all of the costs associated with physical infrastructure. So I no longer have to worry about renting space for my systems, or having air conditioning, or having special power for those environments. I don't have to worry about scheduling time for the IBM engineers to come in and do upgrades to the hardware or to replace cards that have failed. So I no longer have to do anything around managing the actual infrastructure. All of that is being done for me. And I can back up to the cloud. So I no longer have to manage tapes for doing backup. I can simply back things up to the cloud, and I now don't have to worry about packaging tapes up, sending them out to my tape management service, and then getting them back when I need them and figuring out which tapes do I need. It's all sitting up in the cloud. And we'll actually see an example of exactly how that works in just a second. So let's take a look at what that actually looks like. So we'll take a look at the cloud console. So I'm going to flip over now to a demo. We'll actually take a look at it. So here's our cloud console. So here's where I can manage my cloud environment. So what you see here are a bunch of different cloud environments. Now I can start out with templates where I can simply spin up a cloud IBMI with a 7.4 version, or maybe I want to spin up one that has a 7.3 version or a 7.2 version. So I can create these right out of templates that are provided in the cloud. These are actual environments that I've already created. The green ones are up and running right now. The gray ones are ones that are on standby that I can IPL and have running at any moment in time. Now you'll also notice that in addition to IBMI templates, I also had templates for Windows servers or for Linux servers. And so I can grab as many of those as I want to create my entire environment. So an environment can consist of both the IBMI server plus lots of other servers surrounding it. So here I've got one of my demo servers, and if I look at it, I've actually got a whole bunch of CentOS Linux servers surrounding my IBMI. And if I wanted to, I could click right here and power those systems up. So I could IPL all those systems and bring them up. Or if I wanted to, I could create a copy of them, or I could save this configuration that I've created as a template. Or I could add new environments at any time. Now I'm going to go ahead and jump into this environment here. So here we see we've got the IBMI. If I wanted to add some additional VMs around this machine, again, I could come over here, go to one of my templates, and add these VMs as I needed to. So I could just select whichever configurations that I wanted for those machines that I was adding to my environment. Now I can also, right from here, get into the console for this machine. So just by clicking on it, I can actually bring up the console and do work right here on this IBMI. And I can sign into this IBMI and do whatever it is I need to do that. So I can do that directly from here through console access, or I can bring up a terminal and work straight through a terminal. So I have whatever access I need to that IBMI. Now let's take a look at, so I see here that this is a 2 gigabyte IBMI, 2 gigabytes of memory with 80 gigabytes of storage. If I want to, I can actually get in and look at the information about this particular system. So I'm going to go into my settings here, and we'll take a look at the hardware. And here you can see I've got one CPU. If I needed to, I could add more. I've got 2 gig of memory, and again, if I needed to, I could add more. And here I've got 80 gigabytes of storage. If I need to, I can add more. So I can simply, by changing the settings here, I can increase the capacity. Now, in order to do that, I would have to shut the machine down, but I can then go in and increase the capacity of the machine and re-IPL it. And notice here I can decide, do I want to be charged monthly or hourly? So if I'm just going to use it for a very short period of time, maybe I want just hourly charges. If I'm going to use it more permanently, I might want to go with monthly billing. And then I also have a dashboard that I can look at where I can see what's happening with my systems. So over here, I can see for the company, I can see how many RAM hours are we using. I can see if there are any limits. If I put limits on the x86 machines, or if I put limits on my IBM I machine, I can see that information. I can also look at a variety of reports to help me manage my usage of cloud. So if I come in here, I can see things like current usage. So this shows me around the world, how much usage do I have? How much am I using my systems? How much in the different regions that I might have signed up for am I using? So I can see exactly what I'm using at any moment in time. I can also manage my security policies from here. So I can decide how I want things to work from a security standpoint. So what kind of password control do I want to have for people who are getting into the system? I can decide who can actually get at my IBM I. So if I really want to protect my IBM I can say that I will only allow access into my IBM I from these particular IP addresses. So you can only get to my IBM I if you are coming from addresses that I have actually said you can use to get to the system. And I can go in by user in order to manage my costs and decide what are each of these users allowed to do. So I can make sure that users are not overusing my capacity where I will get surprised by costs. So I go in and set up limits where I can say this user can only have 2 virtual machines, they can only use a maximum of 4 gig of memory, and whatever limits I want to put on the user, I can do that. And they can see the reports on their usage, and I can see the reports on their usage. So the idea is I have a totally flexible environment that's secure, that's backed up, and that's easy to manage, and that I have a tremendous amount of power in managing how we use the system. So I can very, very easily clone environments, set up new testing environments, set up new production environments. I can automatically do snapshots to back up my systems if I want to do that. I can set up HADR in the cloud. So I have a variety of things I can do very, very easily by putting things up in the cloud. Okay, so let's talk a little bit about then backing up to the cloud. So if I want to back up my IBM I to the cloud, I can do that. So let's take a look at cloud storage services for IBM I. So cloud storage services allow me to back things up from the IFS or from my IBM I, or to make backups of my libraries from the IBM I into the cloud. And we're going to do an example of actually backing this up to Amazon S3, but you could back up to the IBM cloud as well. So you can choose where you actually want to store your stuff. And it's really easy to do. So what I'm going to do is I'm going to just first take a look at a resource, which would be a cloud place where I'm going to store things. All right, it would help if I put in the correct command. So WRK CFG ICC. Okay, and these are the configurations. So these are different cloud resources that I've created. So we're going to take a look at this one right here. This is my AWS S3. So what we have here is just some basic information. So what is it? What kind of a resource is it? And then what you're not seeing here would be the access key ID and the secret access key. These are things that you get from the Amazon resource so that you can actually work with these cloud resources. These are the security things that allow you to access these on the Amazon cloud. And then this bucket, that's actually the location where we're storing things. So a bucket in Amazon is basically a place where you're putting things. So that's really all you need to do in order to configure the connection to the cloud. So now what I'm going to do is go ahead and copy something up to the cloud. So let's start out by going to work link, and we'll go look at my directory. So I've got this PowerPoint here, and I'm going to go ahead and say I want to copy that up to the cloud. But before I do that, let's actually go in and take a look at the cloud. We're going to go over, look at my Amazon bucket and say, here's my Amazon bucket, and I'll just refresh the screen to show that there's nothing up my sleeve here. So you can see that PowerPoint is not here. So let's go back over here. And we're going to say copy to cloud, CPY to cloud. And we'll go ahead and prompt that. And I'm going to send it up to that AWS S3 resource. And it's coming from home, dmagid, and it's PowerPoint.pptx. So that's the file I'm moving up. And I'm going to call it the same thing in the cloud. And hit enter. And basically that's all there is to it. And I can do now to work status ICC. And let's see if there, and there it is. So now it's actively running and pushing things up to the cloud. So that's happening. Let's exit back out of here. And let's go back over to our cloud. And let's go ahead and refresh. And there it is. So now we have our PowerPoint.pptx, and it's reached the cloud. Now let's go the other way. So I'm going to take this demo.txt, and I'm going to bring that down to my IBM I. So again, if I run back over here to the IBM I, and I go back to my work link, see, there's no demo.txt there. So let's go down to copy from cloud, and we'll prompt that. AWS S3. And now we're just going to say it's coming from demo.txt. And it's going to go to /home/dmagid/demo.txt. And we'll run that. And this actually is a very small file, so it shouldn't take very long. And there it is. So now I've copied that down to the cloud. So I can copy to the cloud, I can copy from the cloud very, very easily using this technique. Now I don't have to do the backups this way. I don't have to manually say I want to copy this file from my IBM I to the cloud. I can actually have BRMS do that for me. So I can use BRMS just like I was using it to back up to tape, to back up to the cloud. In fact, as far as BRMS is concerned, the cloud is simply like another tape drive. It's just another device. So if I go into work with control group, BRMS, you can see I've got a bunch of cloud things. These are created automatically. When you have ICC set up, it automatically creates these cloud control groups for you that you can use for your backups. And I've created one here where I can go in, and what this one is designed to do is back up a couple of libraries on my IBM I. So I'm going to back up this ICC test and ICC test 2. So I have that all set up. All I need to do now is run the BRMS backup command. And I'm going to use that cloud one. And run my backup. And basically that would be all there is to backing up using BRMS. So if I wanted to, I could put the same commands that I use for backing up to tape into my automatic backup process, but instead point them at the cloud and have them back up to the cloud. So you can manually back things up to the cloud, or you can do it automatically. Now, the other thing I didn't show you is probably one of the coolest things is that there's actually a graphical user interface to all of this. And that's what we see here. So this is actually, interestingly, this is an actual native Node.js Angular application running on the IBM I that provides a graphical user interface for doing your copies and your backups to the cloud. So I can go in and select a file and then simply say back it up to the cloud, and it will back it up to the cloud for me. So I can do that from the graphical user interface as well as from the green screen user interface. So you now have a very simple way to move things from your IBM I up into the cloud. So that's a little bit about backing up to the cloud. So we've looked at the console for managing your cloud instances so that you can do your cloning, so that you can do your capacity planning and your capacity building, so that you can manage your resources in the cloud. And then we looked at backing up to the cloud. The last thing we're going to look at is doing DevOps in the cloud. That is actually managing software development and deploying things to the cloud. And basically it looks something like this, where I can actually store all of my IBM I resources in the cloud. So my RPG source code, my open source code, whatever it is I need to, I can store that up in a GitHub repository using Git for my version control. I can edit it using whatever tools I want to use. So if I want to use RDI, I can do that. If I want to use some other tools like VS Code, I can do that. If I want to use standard traditional tools like SEU, I can use those tools. So I make all the changes that I need to make for the projects that I'm working on, and then I can build them using Make. Now, Make is the open source way of building things, but you can actually build IBM I code with Make and then have it deployed to the cloud. So I can do everything using open source. So I'm using open source tools to actually manage my IBM I development process and deploying all those IBM I resources to the cloud. And so now we're actually going to take a look at that process. And for that, I'm going to turn things over to our open source expert, Aaron Magid, and he will show you the actual process of managing a mixed IBM I RPG project that also has open source parts in it, and managing that all through this cloud environment.
All right. Thanks, Dan, for that awesome intro. So like Dan mentioned, we're going to be going through a quick demo of the cloud functionality and what it looks like to actually work with IBM I in the cloud and with modern technology in the cloud. So what that's going to look like in our demo today, we're going to go through three major steps. So first, what we're going to do is we're going to deploy an application to a fresh cloud machine. So that means we've got a cloud machine that has nothing else on it, and we're going to deploy an application to that machine using all open source tools, no proprietary tools of any kind. Then we're going to take a look at how developers work with open source technology and with the cloud and with their ILE assets in the cloud. And then we're going to take that, so that's all going to be in a demo environment. We're going to take that and we're going to look at some real life examples of how this actually works in practice. And we're actually going to use internal Eridani systems for that purpose, because at Eridani, we do everything in the cloud and everything open source. So let's get started. So like I said, the first thing we're going to do is we're going to deploy a brand new application to a cloud machine. So that application that we're going to deploy is represented right here in this GitHub window. Now we'll talk a little bit about GitHub as we move on in the presentation, but for now, just know that GitHub is cloud-based storage for our source code. So we have our entire application, all of the source code, and all of its information in GitHub, and we can view it here. Now, our machine that we're going to be running this application on is accessible actually at this public URL right here, this Eridani Connect test.eridani.com, port 3001. So I'm going to load this page, and you can see that my browser just spins. I don't get a response. So you know that there's nothing up my sleeve. This application is not running on the test machine right now. So if we want to deploy an application to a brand new machine, right? So this is a fresh machine. It's got nothing, no system dependencies. This is a Node.js application. It doesn't even have Node.js installed, right? So it doesn't have anything. In the proprietary IBM tool methods, in the traditional methods, typically in order to set something up like this, you would need a fairly lengthy process to get your tooling installed so that the system would be ready to receive an application and would know everything that it needs to know to build your application on the machine. That is radically different when we work with the open source world. In the open source world, everything we need to know to build the application is stored in the application source code itself. Now, Dan mentioned a little bit about that when he talked about makefiles. Basically, because the application knows how to build itself, all we actually need to deploy an application is the application source code. We don't need any proprietary tools. We don't need any listeners. We don't need any build tools. We just need the application source code and an open source environment. And once we have those things, the application is capable of setting itself up. So, in order to set up the application, step one is to get it onto the machine. We need to get that source code onto the machine. So, I'm going to open up an SSH connection to my IBM. Now, for those of you who aren't familiar with SSH, SSH is effectively the open source world's version in the Unix version of a 5250 connection. Right, so what I've done here is I have created a secure connection to my IBM where I can send it commands and it will send me back the results of those commands. Very analogous to a 5250. So in this directory, I'm going to hop into my directory that I created for this. It's a fresh directory. Okay, so I'm now on my SSH connection. Now, an SSH connection, for those of you who aren't familiar with it, is very similar to a 5250 connection on an IBM. Basically, what SSH allows me to do is send commands over to my IBM remotely, and then my IBM is going to send back the results of those commands to my machine. It's a very analogous to a 5250. So I'm going to open up an SSH connection to my IBM, and it's going to negotiate the connection, set up the encryption, get everything I need. Okay, so now that I have my connection open, I can now run arbitrary commands on my IBM. And so again, we're going to use this to deploy our application to the IBM. So what I'm going to do is I'm just going to move into a directory for this installation. And what I'm going to do is I'm going to come in here and I'm going to tell Git, which is our source control tool. If you remember, I mentioned GitHub earlier, which is a cloud-hosted Git solution. I'm going to use Git to download the source code for my application onto my IBM. Now, for those of you who have been to a conference and have heard about Git, you're probably familiar with some of these commands. For those of you who aren't, long story short, Git is a source control tool. So I use Git to manage the changes that I make to my application and make sure all the source code is in sync with the different versions. And I also use it in conjunction with a cloud-hosted system like GitHub to back up my code and to ship it around to the different machines that it needs to be on. So I'm going to clone my application. Okay. So I tell Git, here's the location of my remote repository where all of my code is, and I want you to download that code. Now it's going to ask me to authenticate. I'll log in. And now you can see, once I log in, it immediately starts flying, and it goes over and it grabs, it figures out what are the objects it needs to get, what are all the files it needs to get, and it's going to go out and it's going to download those and bring those down to my IBM I and set up the whole directory structure within the IFS. Right, so I'm sitting in here in the IFS. I now have my application. You can see if I list out what's in this directory, now there's this Git Cloud demo directory that has all of my source code in it. So I'm going to go over to my Git Cloud demo directory. And if you remember, when I talked about the 3 steps that we're going to go through, what we're going to do is we're going to deploy this, and the application knows how to build itself. Right, so there were 2 steps. I need to download the source code and then tell it to build itself, and it knows what to do from there. So I have downloaded the source code. Now I'm going to say, set it up. Now this is a fairly long-running script because it needs to actually go through and figure out how to download this, all the components for this application, all the dependencies, and get those installed, get everything compiled, build all the native objects that it needs to get. So it may take a bit to run, but while it's running, we're just going to go through and we're going to talk about some of the steps that it's going through, because those are the steps and the tools that those steps use are what make it possible to work with technologies like the cloud and to work with open source technology on your IBM I. So you can see it's spinning away here. It's getting ready to do its installation. So when it hops in to do this installation, the first thing that it's going to do is it's going to go out and it's going to grab all of the dependencies. Right? So these are things that often you would need a proprietary change management tool to do. But in this case, we can do this exclusively with open source tools. So the first thing that it's going to do is it's reaching out to IBM servers and it's saying, all right, what do I need to build this application? What does this application need? Well, it needs Git, it needs Gmake, it needs Node.js, it needs Python, it needs a whole bunch of tools. And so it's going to go out to IBM and it's going to figure out what are these tools and how do I get them onto the machine. Now, our template for our IBM I machines at Eridani already has a lot of these packages installed, which is also a good thing because these installations can take a bit of time to actually download these dependencies and set up the whole environment automatically, though it does do it automatically. And you can see that in here, because we already have a lot of them, it says things like, all right, package patch GNU is already installed and at the latest version. So it went out and it did a version check to make sure that we have all the right software, and all that software is not only the right software, but it's actually at the right version. It's at the latest available version for the software that we're installing. So that's a really important point here when we talk about working with the cloud, is that every time we deploy these things, it gets the latest version of all the software, and it gets the latest compatible version. Right? So that means that our deployments are very, very smooth, and they're very, very easy to automate because all of the components of the application have automated installers that are provided, for example, by IBM or by the open source community that's using them. So we have our system dependencies now. And so the next thing that the installer is going to do is it's going to go out and it's going to grab the Node.js dependencies. So it now has, if we look in the list here, you can see it grabbed Git, it grabbed Make, which is a build tool, it grabbed Unzip, and it grabbed Node.js 12, right? So if you recall, I mentioned before that this is a Node.js application. So it has grabbed our Node.js application, and it has grabbed all of the system dependencies that it needs. And you can see there was a whole bunch of output here. But basically, after this application installer set up PM2, you can see it got it right here, got PM2. The next thing that it did is it initialized our Node.js application, and then it turned to take a look at the native dependencies of this application, right? So this is going in and using that make file that we talked about. So you can see it came in here, it created a library that it needed, and then it compiled our 2 RPG programs. So you can see it placed our programs in our library. We can see the compiler output. in the installer, in the same output from the installer. And if I scroll down past that, after it has compiled all of the assets, it's then coming in and it's generating SSH keys and getting everything that it needs to configure the application. So again, it's going through every single step that it needs to install this application and get it up and running. And we've got some non-source based objects as well. So you can see we've got a job description, we got some data areas coming in. It should be finishing up soon. We're almost there. All right, so now it's finished building those native assets. And so actually what it's going to do now is it's going to use an Eridani tool to generate some of its last remaining dependencies. It's actually going to generate some ILE code. It's going to generate an RPG program and a CL program. And it's done. All right, so our application has finished setting up. It has finished compiling all of its assets. It's finished configuring itself. It's finished getting all of its dependencies, and we are ready to run it. So what we're going to do is we're going to say node src/app.js. And that's going to go in, and it's going to run our application. So we've got our application. All right. So our application is listening. It is listening on port 3001. This is a web application. So we're going to go back to the web browser that I showed you before. And you can see we currently still have our error. And when I refresh my page, all of a sudden I have this nice little web API, this nice little web UI. So our application is now running, and I can actually prove that by coming back over to my terminal. If you look down at the bottom here, you can see that it logged the request that we ran. So it did actually load that web page, and it did load it from this server that we're running from this application that we deployed. If I come in here and I just say I'd like to run a simple calculation, and I click the calculate button, you can see that we get our result back. So we ran our 12, we got our 1200 back because our RPG program is a fairly simple program that just multiplies a number by 100. So we have deployed an application to a fresh IBM I, right? So that was step one of our demo, right? The first thing we're going to do is take a fresh IBM I that has not had this application on it, and we're going to deploy our application from only the source code. And I want to just point out a couple of really important points about what we did in this stage of our presentation. There was nothing in here, not a single step, that required a proprietary tool. Everything in here was fully open source, fully cloud-based. Absolutely nothing required any previous setup. The only previous setup that we actually did was our template already had some system dependencies, which made the automatic installation go a little bit faster. But everything on here, absolutely everything, was installed by the open source installers automatically onto the fresh cloud machine. So now that we have our application, the next question, since we've deployed it, is how do we actually work with our application on this cloud machine? And it is different from when you work with an on-premise machine. Now, there are a couple of differences between working with the cloud and working with an on-premise machine. The most notable difference that a lot of organizations go through, number one, is that we end up with a large number of small machines for individuals. Right? So rather than getting one machine that we work on for our QA, one machine that we work on for production, one machine that we have for our development, one machine for test, what we end up with is very small machines just sort of dotted around the cloud. And that comes with some benefits, and it comes with some challenges that you have to adapt your development process to. So in terms of benefits, it means that I, as a developer, get to work on a completely isolated environment. I don't have to worry about any other developers colliding with the work that I'm doing or causing problems in the work that I'm doing. But on the other side of things, I do have to be conscious of the fact that we are creating these servers, and that means that whenever we create a fresh one, we have to do a deployment. So that means we have to have a very robust system for doing deployments. We have to have highly automated systems for putting out our applications and getting them deployed with very little manual setup. And that's something that we do with the open source system, as you've seen in the first part of this presentation. Now, the second key difference is that we're working with clean environments. Right? So we have a lot of environments. We're working with clean environments. Right? So that means that when I create a new environment, I don't have to worry about other systems that might be, or previous tests, or previous development work, or other developers that might be interfering with the work that I'm doing, or creating an environment that could cause problems or could bias the results of a test that I run. I know every time I create an environment that this is a clean environment and that I don't have anything else. Number 3 on our list is that we're working with disposable machines. And that's a really interesting philosophical change for a lot of IBMI people to work with. Right? So in the past, we're used to working with a big machine that is totally critical and where everything is absolutely needs to be very, very tightly monitored to make sure that we don't cause problems for other developers. When you're working with a teeny little cloud machine that was created only for you, where you can spin up a new one in a couple of minutes, you have a lot more flexibility with what you can do in your environment and with the things that you can experiment with as you're developing. Because the worst case scenario is you cause a problem on your cloud machine and it doesn't affect anybody else. You just take a couple of minutes to revert your template and you're done. You're back to where you were before you made your change. So you don't have to worry about those big danger things that you can run into when you're working on a centralized machine. So looking at how a developer will work with an application like this, one of the big differences, again, is that I have my own machine and I develop locally. Right? So I work on my application on my machine and then I deploy it up to my cloud machine. So let's focus this around a use case. Let's say that we've decided that the factor that this RPG program multiplies by is too large. We're doing 100, we want to change it to 50. So what I have on this machine is I have a local copy of my source code. And what I'm going to do is I'm going to come in here and I'm just going to make a quick change to my application. I'm going to change this to 50. And then what I'm going to do is I'm going to deploy that change, right? Naturally, I want to move that up to my development machine. So I saved that. I'm going to come in here and I'm going to use Git to do this. Right? So if you remember, we talked about Git before. Git is a source control tool. I'm going to check the status of my system. Git allows me to see what changes have been made to the source code on my particular repository since I last checked. I'm going to say Git commit. I'm going to give it a simple message that says what I did in this particular change. And then I'm going to push it. I'm going to push my change up to the cloud system. Now, the first thing that's going to happen is this is going to go to our cloud source control repository. Right? So this is going to actually go up to GitHub. So if I come back to GitHub after I run that push, you can see that right here, it has my latest message. So it has that change. And if I come in here and I open up that simple calc RPG source, you can see that it changed to 50 in here. So it actually has that updated source code immediately. It's in GitHub. And so now what I'm going to do is So I'm going to come back to here. I'm going to stop my server real quick, and I'm going to say, pull the latest code. Okay. And then we're going to say npm run build. And what that's going to do is it's going to go out and it's going to rebuild our RPG programs based on the new source code that it has pulled down from Git. All right, so it has rebuilt it. And so now what we're going to do here is we're going to say node src app.js. Again, we're going to restart our Node.js application. And once that starts up again, we're going to take a look at the web page again and view the updated source code. Okay, so it's listening. And now, all right, so we click the button and we go 12 to 600 this time, right? So we multiplied it by 50. So our change has been deployed to the IBM I, again, doing this exclusively with open source tools to our cloud machine without having to get the proprietary tools set up, right? And that's a really important thing to understand when we look at working with cloud machines, is we have to make sure that our deployment process is very robust, very automated, but also very lightweight so that we can get it set up on brand new instances very quickly. So that's what it looks like when we need to make a change to an open source program or to an IBM I program on a cloud system from our remote development environment. So what we just did is went through and made a change to the application that we developed. So if you remember back at the beginning, I said we were going to go through 3 steps. Number 1, we're going to deploy the application. Number 2, we're going to make changes and we're going to deploy them. And then number 3, we're going to take a quick look at some real life examples of how you actually, of real programs that do this. So what I wanted to point out in this last section before we wrap up is the Aerodani Connect client, which we have installed on this machine. And that is an application that is an Aerodani product. So I'm going to come in here and I'm going to just take a look at this library right here. If I say display lib eConnect, you can see that we have a whole bunch of programs in here, a whole bunch of CL programs. We have some commands, we have some data areas, we have some data queues, some files. We got everything that we need to run our product, the entire system right here. So what I'm going to do, I'm going to delete that library. Okay, it's deleted. Product is gone. So now what I'm going to do is I'm going to reinstall it because naturally we don't want to just delete our program. You can see I actually got a whole bunch of angry output because I forgot to shut down the application before I deleted the library that it was relying on. So it was not happy with me. So you can see that it actually was relying on that library when I deleted it. So what we're going to do is we're just going to come in here and we're going to say npm run install client. And now that install client command is going to go out. It's going to do the same thing that we had in the previous steps, where it's going to go, it's going to grab the source code from GitHub, it's going to download it, and then it's going to go through and it's going to compile all of the assets that we need to build this application. So you can see it's already running. Created the library again, created the source files that it needs for that, and then it's going to start going through and it's going to start recompiling all of those assets that it went through in the original installation. And you can see it's running through it pretty quickly. And there's our demo programs flying by, and then some of the last dependencies. You get our job description, our data areas, our data queues, and we are done. So the application has been fully recompiled. And if I come back here and display the library again, you can see, look at that, everything's back, right? So it just went back through and rebuilt our entire application from scratch, from source code that it pulled down from GitHub when I ran that command. Great, so we're listening on port 3001 again, and we're going to come back to the web browser, refresh the page. You can see we see this again, and then once I hit the calculate button, we're going to get back our result, 12,600 again, just like we got before. So the application is fully rebuilt and running again. Right, so what we just saw was a real life use case of how we do this, because it was really just a couple of commands, but that is actually how we install our products. When we go to a new customer site and we want to install the Aerodonic Connect client, which is a product that we sell, this is all we have to do to install it. We just run those commands, well, minus the delete library. We just run basically the one command, and it goes out and it grabs all the source code and gets us everything we need. We don't need to do the setup. We don't need to get proprietary deployment tools onto the machine. We just use the open source systems. And it's very, very simple. And that also goes for when we're installing internally on test machines, on new development machines. It all just works. And that's one of the critical takeaways of these open source tools. They are so much simpler to set up than a lot of the tools that we're familiar with. We just store the instructions in our source code, and then we can deploy it to a new machine with no prior environment setup, and we're good. So just to wrap this up, what we went through today is a quick demo with 3 major steps. Right, we went through how we actually deploy an application to the IBMI and to a fresh cloud IBMI. We went through what it looks like when we are working with an application on a cloud IBMI and how we connect to it. And you'll notice that aside from a couple key differences, it is very similar to when we're working with an on-premise machine. And then our last step was to just take those sample programs, right? We have a simple sample program where we just multiply a number by 50 now. We took those sample programs and we actually directed that at a real life example of a real product, a real system that gets installed on real IBMIs at all kinds of customers that we work with. So those 3 major steps in working with the cloud and IBMI. So I'm going to turn it back to Dan. Thank you for listening to me. I'm going to turn it back to Dan to wrap us up. But thank you very much. Dan?
Great. Thanks, Aaron. So Aaron showed you how you can manage all of your software development using cloud IBMIs and using cloud resources. So for example, he stored all of his source code in GitHub. So his open source code, but also his IBMI native source code, all stored in GitHub. And that's also where he was tracking the projects that he was working on. When he was ready to work, he downloaded the source code from GitHub to his local machine and edited the code using, I think in his case, VS Code, but it could have been RDI, or he could have been using it on the IBMI editing with SCU. He then stored all that source code in Git, in a local repository in Git on his machine. And when he was ready to test, when he was ready to actually run the application, he simply deployed it to the IBMI and built it so that now he had a build on the IBMI. So the RPG code was built, all the dependencies were built, as well as all of the open source. So he was able to build all of that code simultaneously so he could test his web application. So that's doing DevOps using cloud IBMIs. And as he pointed out, one of the very cool things about that is you can spin up an IBMI, put your changes there and test your changes in complete isolation from anybody else's changes. So you don't have to worry about other people's work interfering with your work as you're testing. And when you're done, you can get rid of that IBMI. So what we've covered so far in this presentation is we covered DevOps in the cloud, We covered the idea of cloning, where you could clone an individual IBMI, or you could clone an entire ecosystem of an IBMI and Windows servers and Linux servers. You could use those servers for upgrade testing, for testing new package releases, for testing your own in-house changes. You could rapidly scale your machines up and down, so you could add capacity or take away capacity as you needed, so that you could pay for just what you needed, so just the capabilities that you were using, and you could eliminate all of the physical infrastructure that you have to manage in an on-premise situation. And we looked at backing up to the cloud, where you could copy individual files up to the cloud, or you could do backups using VRMS to the cloud. So using the IBM I in the cloud gives you a whole lot of flexibility, a whole lot of capabilities that you don't have on premise, and you can manage it in a very cost-effective fashion. So I hope that gives you a good introduction to using IBM I in the cloud. If you have any more questions, please feel free to reach out to us at Eridani. You can reach us at info@eridani.com or at www.eridani.com. And have a great conference. Thank you, everybody.